ratio must be infinitely large. But speaking, this difference amplifier, if it is not ideal, it may to some extent amplify the common mode part also. That means it cannot produce exactly V2 minus V1. So as it cannot produce exactly the V2 minus V1, the sum of the common mode part is also getting amplified. So that amplification, that amplified common mode part at the output, that our intention is to minimize it near to the zero level for proper designing of the difference amplifier. You go through any difference amplifier text, you will find those details in detail. Okay, so that you need to do. Because what I have learned that you have not studied the difference amplifier in electronics class, so you have to study it yourself.
Okay, sir.
Today we'll be discussing, in the last class, we have seen that the operation amplifier in the open loop mode has got almost no application as an amplifier. Why it is so?
Because the linear range is almost negligible.
Why that linear region is negligible small? What is the fundamental reason?
Because the VI value compared to the
due to?
So because the VI
of noises.
No. Oh, why that linear region itself is so small? Why is it
because
so?
the VI value compared to the V0 value is very small.
No.
Very high gain.
AD value is very high, sir.
Gain. It is
Gain
due
value
to
is
the
very high.
fact that the open loop gain is very, very large, 10 to the 5, 10 to the 6 order. That's the basic reason why the operating linear region is so small. And it is so small that is much below the noise voltage level. So as such, the operation amplifier in the open loop mode has got no application as an amplifier. It is because of the almost infinitely large open loop gain. But does it have no application at all?
No, it is used as a voltage comparator.
Application and as comparator. Okay, so that's the application area of op-amp in open loop mode, that is open loop comparators. Now I have given two circuits. In the first one, the input voltage is connected to the non-inverting input terminal, and 2 volt DC is connected to the inverting input terminal. Your task is to draw the transfer characteristics. You please try to draw it yourself. I'll give you 1 or 2 minutes time, and then I'll draw. So that you can verify whether you have done correctly or not. After you finish, you tell someone tell me. I'll just start mine.
Done, sir.
Okay, fine. Now, basically, whether the op-amp is operating in open loop or
Sir, you are not audible.
closed loop does not matter. One thing is pretty sure. In in case the input difference voltage is positive, by the way, are you able to hear me?
Yes, sir.
Yes, sir. মাঝখানে
Fine. মাঝখানে একটা ফোন এসেছিল তাই জন্য বললাম। Whether it is open loop configuration or closed loop configuration, it does not matter. One thing you must always remember that for operation amplifier, in case the open loop, in case the input difference voltage is positive, the output has got to be plus Vset, and in case the input difference voltage is negative, the output has got to be minus Vset. That is always true. Now, positive and negative means definitely not 0.1 millivolt positive or 0.1 millivolt negative. That 0.1 millivolt, I am assuming that to be in the y-axis itself, in the origin itself. So I'm not talking about that. Sufficiently positive and sufficiently negative, I am talking about that thing only. So whenever the input difference voltage is positive, output has got to be plus Vset. Input difference voltage is negative, output has got to be minus Vset. That is universally true. Now, here I have to find out under which condition the input difference voltage is positive and under which condition input difference voltage is negative. Now tell me when input difference voltage will be positive.
And VI will be greater than.
Yeah, when VI is greater than 2 volt. And when will it be negative? No, when VI is less than 2 volt. So it is a 2 volt mark in the VI axis, which is as if acting as a reference point. So let me mark that. Volt. So when the input is greater than 2 volt, output will be plus Vset. And when the input is less than 2 volt, output will be minus Vset. So this is going to be the corresponding transfer characteristics. Please get it verified from your own drawing. Have you got it correctly?
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
Now let me go for the second one. Here, what will be the reference point?
Minus 2 volt.
Minus 2 volt.
Under which condition input difference voltage will be positive?
When VI is
When
less
VI
than
Minus 2 volt.
Less than that reference voltage? When VI is less than that reference voltage? Is it not? Now, when VI is less than that reference voltage minus 2 volt, input difference voltage is positive. So the output is supposed to be?
plus Vset.
So if that is that point, it will be, and beyond VI is more than minus 2 volt, the input difference voltage will be negative. তুমি কিছু বলছিলে শুদ্ধ শুদ্ধ?
না স্যার, না তো হয়ে গেছে স্যার।
শুদ্ধ শুদ্ধ মুম্বাইতে গিয়ে কি তোমার মুখটা ওইরকম হয়ে গেছে?
না 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 স্যার।
ঠিক আছে। Anyway, So this is going to be the transfer characteristic of the second comparator block. So now you see the VI is as if getting compared in the first circuit with respect to 2-volt reference voltage, and in the second circuit the VI is getting compared with the reference voltage minus 2 volt.
স্যার
So,
স্যার
বলো।
ওখানে শুধু 2 ভোল্টের সাথে তো স্যার এওএল এর ইয়েটা থাকবে, সো ওটা 2 ইনটু এওএল হওয়া উচিত তো।
2 into AL এর ভ্যালু কত হবে বাবা? AL এর যদি ভ্যালু 10 to the power 5 হয়, 2 into
হ্যাঁ,
AL এর
স্যার।
ভ্যালু কত হবে?
2 ইনটু 10 টু দি পাওয়ার 5,
তার মানে কত সেটা?
2 লাখ।
2 লাখ ভোল্টেজ তুমি পাবে এখানে?
না স্যার,
কত পেতে পারো ম্যাক্সিমাম?
প্লাস ভি সেট মাইনাস ভি সেট।
তাই তো দিয়েছি, তাই না? So that's why we always say that whenever the input difference voltage is positive, the output is plus Vz. Whenever the input difference voltage is negative, output is minus Vz. This is only due to the fact that the AOL is almost infinitely large. Had your AOL be of the order of 1 or 2, you cannot say that. As your open loop gain is of the order of 10 to the 5 or 10 to the 6 or almost infinitely large, that's why we are saying that we are free to have the assumption that whenever the input difference voltage is positive, output will be plus Vz. Whenever the input difference voltage is negative, output will be minus Vz. Okay, say input difference voltage টা আমার 2 ভোল্ট হোক, 0.5 ভোল্ট হোক, আবার 100 ভোল্ট হোক, does not matter. Okay, fine. আর কোনো কনফিউশন আছে তোমার সমজিৎ?
না স্যার, এখনই নেই।
ঠিক আছে, fine. Now, from these two characteristics, what you find is here, this first one, in the first one, there is one increasing step jump at the output along the increasing direction of the VI. Is it not so? When the input VI is increasing from left to right, it is increasing. There is a step jump in the increasing direction at a particular point. Here, that is 2-volt point. Okay, so in this first transfer characteristic, what we have is there is one increasing step jump in the output for one increasing input voltage. What about in the second one?
Decreasing step.
Yeah, there is one decreasing step jump at the output along the increasing input side. So in some terms, I can say that in the first one, the input and output are almost in the same phase. There is, in the increasing direction of the input, there is one increasing output. Whereas in the second type of characteristics, what we find is along the increasing direction of the input, there is a decreasing output. So this type of comparator characteristics are called non-inverting comparator, and this is called inverting comparator. Non-inverting, in the case of non-inverting comparator, always will find that in the increasing direction of the input, there will be one increasing step jump at the output. Whereas in the inverting type of comparators, we will always find that there will be one increasing step jump at the output along the decreasing input direction. Or along the increasing direction of the input, there will be one decreasing step jump at the output. So that will be always true, whether that is open loop comparator, and then later in some classes we will find that there is something called non-inverting, there is something called closed loop comparator also. How that is implemented on the what is the theory behind that, we'll discuss those in details later. But whatever it is, all the comparators can be characterized in two categories. One is in inverting type, the other one is the non-inverting type. In the inverting type of comparator, in case it is one comparator, be it in open loop or be it in closed loop mode, always the comparators will be having how many output levels?
2.
Always they will be having 2 output levels. One is plus VSAT, the output is minus VSAT. That means the comparators are basically non-linear application of operation amplifier. That means it is having only 2 non-linear output regions. There will be no linear region there. So be it open loop, be it closed loop comparator, there will be always two different output levels. One is the plus VSAT level, other is the minus VSAT level. But be it open loop, be it closed loop, always the comparators can be characterized in 2 distinct categories. One is the inverting type, the other is the non-inverting type. In the inverting type of comparator, along the increasing input change, there will be one decreasing output step change. Whereas in the non-inverting type, along the increasing direction of the input, there will be one increasing step change at the output. So that is the basic difference between the inverting type and non-inverting type of comparators. And it is also guaranteed that in the case of non-inverting comparator, the input signal, the varying input signal will be connected to the non-inverting input terminal, maybe directly, maybe indirectly, and the reference signal will be connected to the inverting input terminal, maybe directly, maybe indirectly. Here we have shown all the direct connections. The input is directly given, reference voltage also directly given. Whereas they may come through indirect mode also. Indirect mode means through some voltage divider it may come. So those are application specific things. But the thing is, in the case of non-inverting comparator, the input signal will be connected in the non-inverting input terminal and the reference signal will be connected to the inverting input terminal. And the reverse is true for the inverting type of comparator. There, in the case of inverting comparator, the input signal will be connected to the inverting input terminal and the reference signal will be connected to the non-inverting input terminal. Now, both may be directly or maybe indirectly. Okay, till this point, there is any confusion?
No, sir.
No, sir.
Fine, thank you. এবার আর একটু জিনিসে যাই। You have to draw the transfer characteristics and the output waveform. You have to draw the transfer characteristics and the output waveform. That is, this has got two different answers. One is the transfer characteristics. That plot is one part of the answer, and the second part is to draw the output waveform. That is the nature of the V0. You have to remember that whenever you are asked to draw the output waveform, you have to draw the output waveform always with reference to the input. That means the time axis must be same for both the input and the output. By the way, is it inverting type or non-inverting type of comparator?
Non-inverting.
Non-inverting.
So what is the reference voltage here?
-1 volt.
1 volt.
So let me mark that -1 volt point. Now, as it by the way, as it comparator, the two output voltage will be two output voltage levels will
VI
be
-1.
no. Two output voltage levels will be
Plus 10 and
Plus
minus
10 minus 10.
-10 volt. So as it is the non-inverting type of open loop comparator, so whenever the VI is more than 1 volt, the output should be
Whenever the V is less, more than minus 1 volt.
-1 volt, sir.
oh, sorry. Whenever my VI is more than -1 volt, the output should be
Plus 10.
Plus
to this point onwards. And when it is less than -1 volt, the output should be fine. But here, another point you must note. The input voltage is specified. What is the input voltage?
6 volt.
6 volt.
6 volt?
Sine wave.
Peak to peak.
Peak to
Peak
peak
to peak
means
sine.
the peak to peak. 6 volt peak to peak AC sine wave. So the input is ranging from which level to which level?
+6 to -6.
Plus
No.
Minus
Plus
3 to
-3.
+3
Yeah,
to -3.
peak to peak. One peak to other peak is 6 volt. That means minimum
Plus
peak
3
to
to
maximum peak is 6 volt. So peak to peak means the total excursion of the input voltage. So that is 6 volt. That means here the amplitude of the sine wave is 3 volt. So the VI is ranging from -3 to +3. So but here I have extended my transfer characteristics beyond that also. If this is your -1 volt, in that case your -3 volt will be somewhere here. So +3 volt will be also somewhere here. So the transfer characteristics must get limited to that particular range of VI. So this should be like this. This should be your transfer characteristic. Is it clear?
Sir, I
Yes,
had a
sir.
question.
বলো।
Sir, 6 volt peak to peak. আমরা কনসিডার করছি +3 -3.
Yeah.
+4 -2 তো কনসিডার করতে পারতাম, মানে
নিশ্চয়ই পারতাম।
জাস্ট
কেন পারলাম না এটার জন্য।
আচ্ছা এসি, হ্যাঁ
পিওর এসি সাইন। দ্যাট মিন্স এভারেজ ভ্যালু ইজ
হ্যাঁ ওকে।
ওটা না দেওয়া থাকলে তুমি যদি বলতে স্যার আমি যদি +6 to +12 ধরি তাহলেও হতে পারে।
হ্যাঁ সেটাই ঠিক আছে।
যেহেতু আমি এসি সাইন বলে দিয়েছি, সো ইউ ক্যানট ডু।
ওকে, হ্যাঁ।
Fine. Now next task is to draw the output waveform. আচ্ছা আমি একটা কাজ করি, সাইনটাকে কেটে ট্রায়াঙ্গেল ওয়েভ করে দিলাম। কেন করলাম?
কোয়েশ্চেনটাকে হার্ড করলেন।
না, আমি প্লট করতে গিয়ে সাইনটাকে কেটে ট্রায়াঙ্গেল ওয়েভ করে দিলাম, সাইন ওয়েভকে কেটে। ওয়াই হ্যাভ ডান দ্যাট? এনি গেস?
সেগমেন্ট লাইন সেগমেন্ট
শুনতে পেলাম না।
স্যার আপনি এখন লাইন সেগমেন্ট ইউজ করে ড্র করবেন তাই?
আর একটু বেশি ভালোভাবে বলতে গেলে আমি সাইন ওয়েভটা ভালো আঁকতে পারি না, ট্রায়াঙ্গেল ওয়েভটা আঁকতে পারি তাই।
এটাই তো বললাম ইনডাইরেক্টলি।
নাইস।
এনিওয়ে, সো আচ্ছা, বাই দ্য ওয়ে এবার আমার 3 ভোল্ট পিকটা দেখে নিই। কি হচ্ছে?
স্যার আমরা কি বেসিক্যালি অপ অ্যাম্পে জেনারেল কেসে গেইনের ব্যাপারে অতটা কনসিডার মানে অতটা কেয়ার করি না?
করি না, তার কারণটা হচ্ছে কি, আমার 10⁵ আর 10⁵ plus 2000 both will lead to the same output at the output.
হ্যাঁ হ্যাঁ স্যার, ঠিক ঠিক।
কিন্তু এটা কিন্তু ইম্পর্টেন্ট হয়ে যাবে যখন আমার গেট 100 হয়ে যাবে।
তো তাহলে
100
তো
আর
op amp
100
হবে না।
plus 10, they will be different. হ্যাঁ বলো, কিছু বলছিলে?
স্যার 100 গেইনে কি অপ অ্যাম্প হতে পারে? মানে will you still consider that an op amp?
এটা ব্যান্ডউইথ এর গল্প বলেছিলাম। For ideal operation amplifier, the bandwidth must be infinitely large. But practically দেখা যায় for IC 741, IC 741 is one typical operation amplifier. Its frequency response looks something like this. This 3 dB frequency is hardly 5 hertz. There it is 10⁵. But after that, there is a roll off. So if you go on increasing the frequency, the open loop gain will also start falling. In the case of IC 741, the UGB or unity gain bandwidth, that means the frequency at which the open loop gain becomes 1, that is 1 megahertz. So if you try to use the IC 741 at 1 megahertz, there your AOL will become 1. If you try to use it at around 100 kilohertz, the AOL will become 10. At around 10 kilohertz, the open loop gain will become around 100. So in this region, the gain and the bandwidth product remains constant, and that is called the gain bandwidth product or the UGB. So for the IC 741, the gain bandwidth product is 1 megahertz. So truly speaking, using IC 741, we hardly ever venture for any circuit application beyond 1 kilohertz. Because if you go for 1 kilohertz, there you know that the unity open loop gain will become how much?
Of the order of 10.
No. If the bandwidth is if the frequency is 1 kilohertz, then what is the gain bandwidth product?
1 megahertz.
1 megahertz. So if the operating frequency is 1 kilohertz, then what will be the gain?
100.
No, 100 can over, 1000 too.
1000.
1000.
Okay, but 1000 also to some extent we can assume that to be quite large. Though it is not too large, but we can, okay, in electronic designs, there is a rule of thumb that anything multiplied by 10 is assumed to be quite large corresponding to the other quantity. তোমরা ইলেকট্রনিক সার্কিট যখন ট্রানজিস্টর সার্কিট ডিজাইন করি তখন ডেফিনেটলি এই রুল অফ থাম্ব ব্যাপারটা পড়েছো। Anyway, so using IC 741, we hardly ever go for any application beyond the kilohertz range. Most of the time we try to limit it lower than 1 kilohertz. If you have to go for higher frequency applications, there you have to go for a choice of one operation amplifier having much larger gain bandwidth product. Maybe 10 megahertz, maybe beyond that also, 100 megahertz like that. Okay, so there are certain situations where the open loop gain may become less than 100 also. Okay, এর অ্যাপ্লিকেশন কোথায় হয় গেটে সেটাও আমি তোমাকে বলে দেবো, অলরেডি এরকম কোশ্চেন আমি দেখেছি। কোথায় ছিলাম? What will be the output? Let me move it. What is the reference voltage?
-1.
-1.
So that also I need to put. When do we expect one state change out? When do we expect any change at the output?
At -1.
-1 volt.
Whenever, no, truly speaking, definitely at -1 volt, but truly speaking, whenever the input voltage crosses the reference line -1 volt.
Yes.
Is it not? Whenever the input voltage crosses the reference voltage, there expect certain state change at the output. If the input crosses the reference voltage in the positive direction, as it is one non-inverting type of comparator, we expect one positive state change at the output. If the input crosses the reference line in the negative direction, we expect one negative state change at the output. Throughout this portion of time, what is the input voltage? What is the relationship between the input voltage and the reference? Throughout this time interval, what is the relationship between the input voltage and the reference voltage?
Input
voltage is greater than the reference voltage.
input voltage is greater than the reference voltage. If the input voltage is greater than the reference voltage, my VD is input difference voltage is
Plus we said.
Plus we said.
positive. So no, input difference voltage is positive. So as the input difference voltage is positive, my output has got to be plus this. Fine. আচ্ছা আমি আরটা কাজ করে নিই এই জিরো রেফারেন্স ক্রসিং যে টাইম ইনস্ট্যান্ট গুলো সেগুলোকে প্লট করে নিই here over this interval, the input is less than the reference, so output is got to be minus V set plus V set. ওকে কোন ডাউট থাকলে বলো
No, sir.
Fine. What will happen to the output here?
So plus V sat for greater than 0. And
So whenever my
Minus-
VI is positive, output is plus V set. Whenever VI is negative, output is minus V set. It will be something like this. Okay. So rather, as if here the output is telling you the time instant when the input signal is crossing the zero line. If you go for the plotting of the output with reference to the input, the output will have a state change whenever the input is
Crossing
the
zero.
reference line.
crossing the zero line. Crossing the zero line. When the input crosses the zero line in the positive direction, output will be plus V set. Rather, it will have a state change to the plus V set. And when the input is crossing the zero line in the negative direction, the output will have a state change and attain the minus V set level. So this particular configuration is called the ZCD, zero crossing detector. So that is a ZCD, zero crossing detector. So there are many applications of op-amp open loop comparator as ZCD. So whenever the input is crossing the zero line, that is basically one comparator itself, where the reference level is nothing but zero. That's the main difference. Now, if my VI is one sine wave, what will be the nature of the output?
Same থাকবে।
Square wave.
Yeah.
Same money, square wave.
Square wave.
So the output will be having only two levels. So that will be nothing but one square wave. And what will be the duty ratio? If that input is pure AC. If the input is pure AC sine wave, what will be the duty ratio of the output square wave?
50%.
50%. Isn't it?
Yes, sir.
Yes, sir.
But
Yes, sir.
if the input is having positive DC, what can you say about the duty ratio?
Reduces by from 50%, less than 50%.
Will it be less than 50%? It is having positive DC.
It will be greater than 50%.
Yeah, it will be greater than 50%, isn't it? Positive DC মানে কি বাবা?
Sir, how can it be more than 50%? It will stay at 50% না?
কেন?
ও হ্যাঁ হ্যাঁ স্যার সরি স্যার
আমার এই ডিউরেশনটা তো বেশি হয়ে যাচ্ছে,
হ্যাঁ স্যার
তাই না? So if this is having positive DC, the duty ratio will be more than 50%. If it is having negative DC, the duty ratio will be less than 50%. And if it is a purely AC, this will be having a 50% duty ratio, exactly.
Yes, sir.
So this type of configuration is also applicable as one sine wave to square wave converter. Remember, the frequency will, fundamental frequency will remain the same. There will be no change in the frequency. Only the duty ratio may differ if in case to case. Case to case means for pure AC, but the duty ratio will be something. For non-pure AC, that means AC with some DC shift, there will be something else. Some non 50% duty ratio square wave will be getting. But the frequency will remain the same. Is it not? Will the frequency differ?
No, sir.
No, sir.
So frequency will remain the same. So that's why this has got many applications in the field of waveform conversion, and that converted wave is the wave is the square wave, and the input maybe sine wave, maybe triangular wave, maybe any other thing also. So this has got some applications in the waveform conversion also, and mostly speaking, we go for ZCD or your what do I say that sine wave to square wave conversion, triangular wave to square wave conversion type of applications. What is the range of values of V1? What is the range of values that you'll have at V1?
So 0 to 10.
0 to 10.
0 to 10 millivolts.
That is 0 to 10. If this node is V2, what is the range of voltage that is available at V2? Roughly.
So 0.1.
0 to 0.1.
Okay. Now, if I make it,
Sir, eklo millivolt hobe na?
0.1 volt, that means 100 millivolt, isn't it?
So 0 to 10 volt, sir, hobe na? V1 0 to 10 millivolt hobe na, sir?
You know,
কারেন্টটা মিলিয়ে যাচ্ছে
মিলিতে কেন হবে?
ও আচ্ছা আচ্ছা না স্যার কারেন্টটা মিলিয়ে হবে
স্যার V2টা আরেকবার বলতে পারবেন?
হ্যাঁ, তোমাদের বাকি যারা বলে তাদের কি আগে বলতে বলো, তারপর আমি বলছি।
তো 1/1 plus 100.
So আমার কি this is
আচ্ছা,
acting
V2
as your voltage divider?
হ্যাঁ
Yes, sir.
voltage divider.
Huh? So 1/101 times V1. Approximately 1/100 times V1.
Yes.
Fine. In place of this 100K, if I use 1K, and here if I use 10 ohm, will there be any difference?
No, sir.
No, sir.
Will you still continue to get V2 is equal to 0 to 0.1 volt, roughly?
Yes, sir.
Good. Anybody is differing? Ankit?
So question repeat করবে একবার?
I have replaced that 100K resistance by 1K resistance and 1K resistance by 10 ohm.
আচ্ছা।
Then also the arms are in the ratio of 100:1, probably. Is it not? Yeah, it is so. In that case, do you think that V2 will continue to give the voltage in the range 0 to 0.1 volt? There's almost one consensus that it will continue to remain in the range 0 to 0.1 volt. Anybody is differing? Nobody?
স্যার এই গ্রাউন্ডের সাথে যদি 100K টা লাগানো হয় তাহলে কি ওটা শর্ট সার্কিট মতো হয়ে যাবে, মানে ওখানে কারেন্ট যাবে না এত হাই রেজিস্ট্যান্স?
গ্রাউন্ডের সঙ্গে 100K?
স্যার মানে ওই 1k টাকে 100k টাকে রিপ্লেস করবে বললেন না ওটা?
না তা তো বলিনি। আমি যে 100k is getting replaced by 1k resistance.
ওকে ও স্যার
And this value is getting replaced by the 10 ohm resistance.
হ্যাঁ স্যার ঠিক আছে।
Okay. So that means the V2 will continue to remain in the range 0 to 0.1 volt. Okay. Fine. Thank you. এবার আমি একটুখানি চেঞ্জ করছি। Let me redraw that particular portion. If you okay, let me do one thing. Let me go for the maximum possible V1 value. When you will be getting the maximum possible V1 value for which wiper position?
Top.
Yeah. Okay. When it is coming here, connected here, is it not? Is it not? The
Yes, sir.
maximum V1 value will be available when the wiper position is in the topmost position. And the 0 when the wiper position will be at the bottommost position. Okay? Hope this is clear. Fine.
Yes. Yes.
Now I am going for the modified resistance values. I think this is something like that. 10 ohm is 0.01k. ঠিক বললাম তো? হ্যাঁ। Fine. Now tell me what will be the value of V1? Will it remain as 10 volt?
No, sir.
There will be the loading effect. Is it not?
Yes, sir.
This part is acting as the load of this output. Now this load impedance is less than the output impedance of this output terminal. So there is definitely going to be certain appreciable loading effect. Had there been low load, V1 would be plus 10 volt. But as the load impedance is nearly 1k, that is much below the output impedance of this circuit. So your output voltage is expected to be much below that open loop output voltage of 10 volt. Now what will be it now? Now it will be now this V1 will be 10 parallel 1 by 5 plus 10 parallel 1 into 15. That will be your V1 value. Is it not?
Yes, sir.
So that V1 value itself will not remain in that plus 10 volt maximum value. So how can that V2 continue to remain 0.1 volt maximum value? That will be much below that. And that maximum value will be governed by this one, this equation. Okay, is it clear?
Yes, sir.
So now I think you should be able to understand. কোথায় গেল আগের সার্কিটটা? Yeah. Here, why we have gone for 100k and 1k?
হ্যাঁ স্যার বোঝা যাচ্ছে।
Now, I have told you now there is a one theory that or there is one concept that there is something like rule of thumb. Anything multiplied by 10 is supposed to be much higher than the other quantity. So this is 10K and that fellow is 100K. So that is more than, that is 10 times the this particular output impedance. So that is assumed to be much higher than the output impedance. So it is expected that the loading effect will be minimal. So now you can
কনসেপ্টে কি বললেন আরেকবার বলুন।
rule of thumb. Rule of thumb তোমরা এতে রেফারেন্স সার্কিট পড়োনি, ওই যখন ওই এমিটার বা বাইপাস ক্যাপাসিটর ওগুলো যখন ইউজ করেছিলে, কাপলিং ক্যাপাসিটর হ্যান তেন ওইগুলো যখন ডিজাইন করেছিলে, দেয়ার ওয়াজ এ কনসেপ্ট that if there is a parallel combination of resistance and capacitance, we choose the capacitance value in such a manner that the capacitance value is 1/10 of the resistance. So that means that in that operating frequency, the capacitance becomes dominant over the resistance. Okay, so there is a very wide concept of rule of thumb in electronic design. And in that rule of thumb, anything multiplied by 10 is supposed to be much higher than the other one.
স্যার একবার অন্য পেজটা একবার দেখাবেন, ওই লোডিং এফেক্টের পেজটা।
কোথায় গেছে কে জানে? এটা?
হ্যাঁ স্যার, হ্যাঁ ঠিক আছে।
সব ঘেটে গেছে। Fine. Now, what is this? How many terminals are there?
2 output terminals.
No. There is one, there is a 3-terminal device. কোন 3-terminal device তোমরা স্টাডি করেছো?
BJT,
না, BJT করেছো। Apart from that?
CMOS, MOS।
হ্যাঁ, ট্রানজিস্টর বাদ দিয়ে।
আচ্ছা,
Sir, op amp is the 3 terminal.
ওপেন তো ইন্টিগ্রেটেড সার্কিট ডিভাইস বলতে আমার ওই বেসিক যে ডিভাইস গুলো, ডায়োড, ট্রানজিস্টর, ওই লেভেলের। পাওয়ার ডিভাইস কি কি পড়েছো? সিলিকন কন্ট্রোল রেকটিফায়ার, এসসিআর।
আচ্ছা স্যার, ওটা একবারে ফার্স্ট সেমিস্টারে পড়েছিলাম কিছু।
ফার্স্ট সেমিস্টার বা ফার্স্ট ইয়ারে বোধহয় পড়েছো বোধহয় ওটা, নাকি নাকি সেকেন্ড ইয়ারে পড়েছো?
স্যার ফার্স্ট ইয়ারেই ছিল, ফার্স্ট সেমি
একদম
ছোট করেছিল। ইয়েস স্যার,
ছোট ছিল।
How many junctions are there? How many layers are there? Diode you have 2 layer by 1 junction. BJT how many junctions? In BJT how many junctions are there? 2. In SCR there will be 3 junctions, PN.
Yes, sir.
Okay. Now in this SCR, there will be one anode, there will be one cathode, and there will be a 3rd terminal that is called the gate terminal. Anode, cathode, and gate. Now, for the SCR to this is basically one switching device. The SCR normally we use in all power applications. Rather than as power switch, so that means that you want to start one pump. The pump requires very high power consumption. There, the driving circuit requires certain high power switch. Those switches are normally those electronic switches are normally made of SCR type of devices, silicon control rectifier type of devices. Now, how does the SCR operate? As SCR is a switch, how many states can be there? 2. One is the on, the other one is the off. Either it is saturated or conducting or non-conducting. Either is conducting or non-conducting. Now, even if you supply some plus minus voltage here, and even if you go on increasing that voltage difference, you cannot turn on that SCR. The SCR will remain off until and unless it is fired by one gate pulse. Through the gate, you have to send one conducting pulse. As soon as the gate is triggered, the SCR will be turned on. And once the SCR is turned on, you cannot turn the SCR off by controlling the gate. The gate has only control over the SCR while turning it on. Without gate pulse, the SCR cannot be turned on from the off state. But to bring the SCR to the off state, you have no other option but to break this current path. Once the SCR is on, the current is continuously flowing from the anode to cathode. If you can break that current path, then only you can turn the SCR off. So normally what you can expect is there is one power supply. There is one load, RL. If you send one current pulse here, gate pulse here, the SCR will be turned on. So there will be a current flowing through the RL. And once the SCR is on, there will be continuously current flowing through the RL. How can you stop this SCR? How can you switch off the SCR? By breaking the current path. So to break the current path, what you need to do is you have to insert one switch here. So what do we normally do? We close the switch. So now the path is possible for conducting current from plus V to ground. But it is not conducting current because the SCR is still off. Now, as soon as I give one current pulse here to the gate terminal, the SCR is turned on. SCR is turned on means as if the plus V is available here itself. So there is a continuous current flowing to the RL. Now, how can you break the current?
Open the switch.
Yeah, you just simply open the switch. So that's why in that SCR current path configuration, current loop or current path, always you will be having certain switch. Unless and unless you open the switch, once the SCR is on, it will continue to conduct current. Okay, fine. Sorry. So this device is that SCR. So initially what we are doing is we are closing the switch SW. But the current will not immediately start flowing from the 15 volt to the ground. Using a meter, say voltmeter or multimeter or oscilloscope, whatever it is, you go on monitoring this V0 output. The output of the comparator or the op-amp is V0. So what are the possible voltage levels of V0?
Plus minus V set.
Now, either plus V set or minus V set. Now, in case V0 is minus V set, can there be any gate pulse?
No, sir.
No, sir.
Okay. So initially what we are doing is, and under which condition V0 will be minus V set? Under which condition V0 will be
VT is
minus
less
V2?
than 0.
No. V3 is less than V2.
V2.
Okay. Now, what is V3? Where from you are getting the V3? This is one microphone. So, from the acoustic noise, it is picking up the acoustic signals and generating one electrical signal. So, V3 is basically whatever sound it is capturing. It's a voltage corresponding to that particular sound. In the normal environment, this is basically that will be nothing but your noise voltage level. Noise voltage level. No, the acoustic noise, the voltage corresponding to the acoustic noise. Okay, at any place you will be having certain sound noise. Even if you are not talking nothing else, but some stray noise is always coming. So this V3 will be the voltage equivalent for that acoustic noise signal.
Sir, V2 to 0 to 0.1 voltage range আছে না?
So that noise equivalent voltage, so that will also be a very small level.
So কিন্তু theoretically even the noise can turn the op amp on না যদি 0 তে থাকে আর যদি 0 এর বেশি এটা থাকে।
Definitely that can turn on. But what we'll be doing is we'll be moving the wiper position in such a manner that initially let me have my V2 more than V3.
Sir, ঠিক।
Okay, so but you can definitely adjust these resistance 5K, 10K, those resistance values you can always adjust. If you need something more than 0.1 volt at V2, you will definitely change that 10K to somewhat more. Let it be 20K, let it be 15K, whatever it is. Let it be 25K, doesn't matter. So that adjustment can be always done. So now initially what we'll be doing is let us place the V1 wiper position in such a manner that V2 becomes just more than V3. How will you find that? That V2 becomes just more than V3? Let me start again. The initially the switch is yeah, that's true. Initially let me open the switch. So that means I am forcing the SCR to be in the off condition. So can the alarm start giving indication?
No, sir.
Fine. So now you are monitoring the V0 using some meter or oscilloscope. Let us keep V1 level initial 0 minimum position. So what will be the input difference voltage of the comparator? If V1 is the minimum position, what will be the V0 level?
0.
Yeah, no. V2 is the minimum
1, 2.
Plus
One.
V0.
V3.
Tell me that first. What will happen to VD?
V3.
Will be positive.
I am not interested. Whenever you are going for the comparator application, you are never interested in actual value. What you are interested in the sign only. Positive or negative? We told you,
Positive.
for comparator application, whenever the VD is positive, output is plus V. Whenever the VD is negative, output has got a minus V. So we are only interested in the sign only. So when V1 is the minimum position, the input difference voltage is positive. So if the input difference voltage is positive, what will happen to V0?
Plus VSAT.
Plus VSAT. Now you are gradually moving the V1 up, the wiper up. So V1 is increasing, V2 is also increasing. So input difference voltage is decreasing. there will be a point of, there will be a position of the wiper where V2 is becoming just higher than V3. So in that position, the input difference voltage has become
Negative.
just negative from the positive. And at the output, how will that be reflected?
Minus V set.
The output has switched to the minus V set at that particular wiper position. So we are monitoring the output signal at the very wiper position where the output is switching its states from plus V set to minus V set, will freeze the position there itself. So what is the significance of that position? Now this position corresponds to, leads to one V2 value, which is
Just higher than V3.
higher than the V3 value. Now what is the V3, current V3 value corresponding to? The atmosphere noise
Acoustic.
voltage equivalent. Acoustic noise equivalent voltage. Okay? Fine.
So,
Now, বলো বলো।
স্যার অ্যাকাউস্টিক নয়েজটা তো এটা তো ভ্যারি করতে থাকে না, তো এটা
ভ্যারি করতে পারে, তার জন্য আমরা ওই জাস্ট ইট ইজ গ্রেটার দ্যান দ্য অ্যাকাউস্টিক নয়েজ বলে দিয়েছি। এবার সেখানে যদি নয়েজটা হঠাৎ করে বেড়ে যায়, ডেফিনেটলি ইট উইল ম্যাল ফাংশন।
ওকে স্যার,
ফাইন। নাও উই ক্লোজ দ্য সুইচ। Will the SCR start flowing current?
No sir.
Why no?
Sir, we didn't still
V0
receive any
is
gate
minus
pass.
V set.
Minus
V is minus V set.
Yes sir.
Okay. Now, you just give one clap in front of the microphone. What will happen? As soon as you clap in front of the microphone, the resultant instantaneous V3 value will be
Greater than V2.
More than V2.
more than V2. V0 will become plus V set. So your SCR will get the current. As soon as SCR gets the gate current, it will be turned on. As it is turned on, the alarm will start giving indication, maybe visual, maybe audio.
স্যার ওর গেটটা যে অন, স্যার গেট অন হয়, স্যার গেটটা যে অন হয় ওটা পালসে অন হয় নাকি মানে
Pulse. It has to be some gate current.
মানে
আমার
after
এখানে
the pulse is
that if the current is like this, does not matter. If the current is, that also be the same thing. As soon as certain gate current is available, it turns on, and once it is turned on, there is no function of the gate.
okay sir.
Gate becomes redundant then. So whether the gate current pulse or gate input voltage is of this nature or this nature does not matter. Once it is given the gate current for a very brief moment, for sufficient, that brief moment must be sufficient moment that it should be able to turn on by that time. So if that is there, it will be turned on. And once it is turned on, there is no effect of the gate, no control of the gate.
So if we open the switch while it is high and then we close the switch, will it be on or will it be off after that?
Arga bolo.
So মানে if it is on, মানে we have an input pulse and the মানে এখন যে স্টেটটা আছে that is high and we open the switch.
Say my gate is something like this. Okay.
Yes sir.
Now that means my SCR has turned on at this point of time because my switch was in contact position. Now here I have opened the switch. You mean to say that?
Yes sir.
So if, that means as soon as you open the switch, the SCR is off. But
Yes sir.
the very moment you close the switch again, as the gate is still on, gate pulse is, gate voltage is still on, it will be getting the gate current once again.
Okay sir.
So it will become turned on. Okay.
স্যার তাহলে এটা অনেকটা লেভেল ট্রিগারের মতো, তাই তো?
Some sort of that.
Yes, sir.
Level trigger ঠিক বলতে পারো না, it is some sort of you cannot say in that manner. Yeah, to some extent you are right. It is some sort of level sensitive with respect to the gate pulse or the
Okay,
gate
sir.
input voltage. Fine.
স্যার আরেকটা জিনিস স্যার, এসসিআর এর মানে ওয়ান্স উই টার্ন অন ইউজিং দ্য গেট পালস, আমরা যদি এটাকে স্টপ না করতে পারি তাহলে মানে ওটার মানে কিসে ইউজ হয় তাহলে?
এই যে তোমার ধরো বেসিক্যালি whenever you are using any power control device, যেমন ধরো ফ্যানের যে রেগুলেটর, ইলেকট্রনিক রেগুলেটর গুলো,
ইয়েস স্যার।
সেগুলোই কিন্তু আমার ওই অনেক দামি যে ইলেকট্রনিক রেগুলেটর, সেখানে কিন্তু এসসিআর কন্ট্রোল থাকে। তো ওখানে এগুলো তোমাদের যখন পাওয়ার ইলেকট্রনিক্স পড়বে সেখানে তোমাদের বোধহয় একটা পাওয়ার ইলেকট্রনিক্স পেপার রয়েছে, there you will have to study this thing. আমার যে সাইন ওয়েভটা এরকম হয় তো, এবার আমার এসসিআর এর ওই অন হচ্ছে কখন, সেটা আমার এই পজিশনে যদি অন হয়, আমার ফ্যান কি এসিতে চলে না ডিসিতে চলে? বাড়ির যে হাউস হোল্ড ফ্যান, ডাজ ইট অপারেট ইন এসি অর ডিসি?
ডিসি।
হ্যাঁ, মাল লাগাবো।
এসি।
সো এসি আমার 230 ভোল্ট সাইন ওয়েভ বা এসি সাইন ওয়েভ রয়েছে। নাও ইফ ইউ switch on the that sine wave at this particular time instant, তাহলে over this 360 electrical degrees of the sine wave, how much you are getting? The full sine wave you are getting?
Yes, sir.
But if you start the input, that means this is one your input and your output is also the same. But if you switch, next page jai. এবার যদি আমি এসসিআরটাকে ফায়ার করি এই টাইম ইনস্ট্যান্টে, that means prior to this gate pulse, there was no conduction in the current in the circuit. So that means the output was something like this. This I am drawing only this half.
Yes, sir.
So average power content of this part is definitely much less as compared to this part.
Yes, sir.
Yes, sir.
So the speed will be lower. আমি যদি এইখানে সুইচ টার্ন অন করি, in that case only this part will be available. So average AC power that is being given to the fan is much less. So very slowly ফ্যানটা রোটেট করবে। So কি করে সেগুলো করে সেই গল্পগুলো আমাকে যদি ঢুকতে, that will be too much. So when you will be going through that power electronics class, definitely these all concepts will be there.
Okay, sir. Thank you, sir.
Fine. So now কোথায় ছিলাম? We have given one clap just in front of the microphone. So as soon as you give that clap, what happens is your V0 becomes plus V set And as V naught becomes plus Vsat, the SCR gets the gate pulse or gate current or gate voltage. So SCR becomes turned on and the current flows to the alarm, and the alarm starts giving you indication. How long will it go on giving you indication? Oh, by the way, is not remaining plus Vsat always?
No, sir.
It will be plus Vsat only for the duration of which the effect is there.
Yes, sir.
And after that, once again, V3 will be corresponding to the noise, atmospheric noise, acoustic noise level. Okay? So there your dot is expected to be minus Vsat. But it doesn't matter. Once the SCR is on, that will remain on. So the alarm will continuously go on giving you a visual or audio indication till your switch SW remains on. Once you put off the switch or disconnect the switch SW, then only the alarm will be turned off. Is it clear?
Yes, sir.
So this
Sir,
is
exactly.
what the clap switch normally works in this manner. In your class 2 level, many of you might have gone for some project on the clap switches. Some students may do it in home also. So there, the clap switch concept is only based on this comparator, open loop comparator. Now, this has got some other applications also. See,
10K এর পরে ডায়োডটা দেওয়ার কি রিজন?
it is just for protection এর জন্য একটা দেয়। কেন কি এটা যখন মাইনাস Vsat V নটটা সেক্ষেত্রে যাতে করে একটা এক্সেসিভ নেগেটিভ ভোল্টেজ যেন গেটে না পড়ে।
ওকে
স্যার
হ্যাঁ
স্যার আমরা যেখান থেকে V1 টা নিচ্ছি স্যার ওখানে 10K টা ভ্যারিয়েবল আছে, তারপরে 1000K টা আছে, হ্যাঁ 100K টা আছে। স্যার ওখানে যদি শুধু একটাই মানে হায়ার ভ্যারিয়েবল যদি রাখতাম,
হায়ার ভ্যারিয়েবল বলতে
হায়ার ভ্যারিয়েবল রেজিস্ট্যান্স যদি রাখতাম তবে স্যার অসুবিধা কি ছিল?
এবার
মানে
এখানে কি হচ্ছে তার তোমার এই যে ওয়াইপারটা ভেরি সেন্সিটিভ হয়ে যেত, তাই না? ওয়াইপারটাকে পজিশন চেঞ্জ করে 0.01 ভোল্ট লেভেলে চেঞ্জ করা ভেরি ভেরি ডিফিকাল্ট। ওয়ারেজ ওয়াইপারটা V1টা চেঞ্জ করে আমি ভোল্ট লেভেলে আমি চেঞ্জ করতে পারছি ভেরি ইজিলি, 0.5 ভোল্ট 0.6 ভোল্ট সেই লেভেলে নিতে পারছি। এবার তারপরে একটা ফাইনাল আর একটা ডিভাইডার দেখে সেটাকে আউট ডিভাইড করে মিলি ভোল্ট লেভেলে নিয়ে গেলাম।
ওকে স্যার,
মানে রেজোলিউশনটাকে বেটার করা হচ্ছে, মানে ওই ফাইনাল রেজোলিউশন অ্যাচিভ করতে আমার খুব সুবিধা হচ্ছে এটা। আদারওয়াইজ ডেফিনেটলি লজিক্যালি বা থিওরিটিক্যালি তুমি করতেই পারো, শুধু এই V1টা দিয়েই তুমি মানে এই পার্টটা ইউজ না করেই তুমি ডাইরেক্টলি এটাকে বলবে যে ইনভার্টিং ইনপুট টার্মিনাল লাগিয়ে দেবো। লজিক্যালি করতেই পারো এটা বা থিওরিটিক্যালি করতেই পারো, বাট প্র্যাকটিক্যালি সেটা অ্যাকচুয়ালি ইমপ্লিমেন্ট করা ভেরি ডিফিকাল্ট, ওই রেজোলিউশনটা অ্যাচিভ করা। হ্যাঁ, যেটা বলতে যাচ্ছিলাম হ্যাঁ কেউ কিছু শুধু শুধু কিছু বলছিলেন?
স্যার এই লাস্টে সুইচটা কে কন্ট্রোল করে?
ওটা হিউম্যান বিইং। তুমি
তাহলে তো মানে if we clap and then we have to stop it, we have to manually মানে সুইচ ইট অফ, কিন্তু এটা তো হয় না।
ম্যানুয়ালি ইউ হ্যাভ টু সুইচ ইট অন।
আচ্ছা, মানে অটোমেটিক্যালি ক্ল্যাপ। ও হ্যাঁ ঠিক ঠিক ঠিক।
এবার তুমি চাইলে সেটা এই সুইচ কন্ট্রোলটা অটোমেটিক ভাবে করতেই পারো, তার জন্য আলাদা লজিক সাইকেল লাগবে।
হ্যাঁ স্যার, হ্যাঁ ঠিক।
সেটা যেরকম অ্যাপ্লিকেশন হবে সেই অনুযায়ী ইউ হ্যাভ টু ডু ইট। হ্যাঁ রাজদীপ
স্যার, এই পুরো সার্কিটটার কোনো নাম আছে, মানে এই পার্ট অফ দিস
সাউন্ড অ্যাক্টিভেটেড সুইচ।
ওকে। আর স্যার ওই 100K আর 1K যেই কম্বিনেশনটা ভোল্টেজ ডিভাইডার ওইটা কি ওটার কাজই হচ্ছে ওই মানে ফাইনাইট রেজলিউশনটা অ্যাচিভ করা?
অ্যাচিভ করতে হেল্প করা।
ওকে স্যার।
কি হচ্ছে আজকে? হ্যাঁ, যেটা বলতে চাইছিলাম, you must have used digital cameras or analog cameras also, and in very good cameras you have electronic flashes. How the flash operate? How does the flash operate? The principle.
Sir,
How does
repeat
the
করবেন
flash
একবার।
বলো?
Sir, questionটা একবার repeat করবেন।
But in camera, how does the principle of operation of flash?
So it switches on and we click the picture and it switches off.
ওই যে হঠাৎ করে you are getting that flash of light. Where from the?
So from some electrical signal, it is activating the flash.
No, physically where from it is coming?
We are
There
pressing
must be some discharge is there. So what happens is, some capacitor discharge type of thing is there.
Yes.
Some charge is stored in the capacitor, and when you press the flash switch or the camera switch, the two terminals of the capacitor are shorted. So almost instantaneously, the charge current is decaying, and that leads to the flash of light. Okay, so basically, in the flash switch or the camera switch is basically acting as the short circuit.
Yes.
Now, what we do is we select that from these two terminals, you connect, you replace that mechanical switch of the flash of the camera and connect these two terminals there. Okay. Now what will happen? As soon as that SCR is on, this will be shorted, these two terminals, or truly speaking, sorry, not these two terminals, we have to connect these two. Okay, as soon as the SCR is on, these two terminals are shorted. And if you connect these two terminals to the flash terminals of the camera, as soon as the SCR is on, the flash will be on. And how long that flash light is available?
Moment of pressing the switch.
Time of discharge.
For the duration over which that discharge current or discharge pulse is available. So that
Yes,
is available for a very, very brief moment of time. Okay, fine. Now let me go back. Let me close the switch SW. So and we move before closing the SW. I move the.
স্যার কোন দুটো টার্মিনাল ইয়ে হবে, শর্ট করা হবে?
এটা না SCR এর।
ওকে ওকে।
Initially, let me put V1 to the bottommost position, the wiper in the bottommost position. So it is ensured that V0 is minus Vsat. Let me switch off the switch condition. That means disconnect the switch SW. That is make switch SW open. Let me monitor the position of the voltage level of V0. It should be initially plus Vsat. Now let me move up the wiper up for V1. So I'll stop the V1 position, the wiper position, as soon as the output voltage V0 becomes minus Vsat from the plus Vsat. So that corresponds, that implies that my V2 level is just higher than the ambient noise at acoustic noise equivalent voltage. Now I close the switch SW. What we'll do is we'll say put out all the lights of the room. Put the camera shutter on. Rather, open the camera shutter. If there is no light, what will happen? Can any image be captured?
No, sir.
Fine. Now, in the dark room, you fire one bullet. As soon as you fire the bullet, some sound is available. As the sound is available,
Yes.
that sound ensures V0 to switch to plus VSAT. What will happen is, as soon as that sound is available, the SCR will be turned on. And as soon as the SCR is turned on, what will happen to the flash?
Flash will be
Will
on.
discharge.
Flash will be on, the capacitor will discharge and the flash light will be available. So in that light, whatever things are visualized, that its image will be captured by the camera. So we can get one image, mid-air image of the fired bullet in this particular method. Just after firing the bullet, if I get the corresponding image mid-air, I will be getting the image of that particular bullet in mid-air. And the flash duration, remember that flash duration is very small. So in that small duration, only light is available. Before and after that duration, there is no light available. So you just get the image of the bullet, take it, close the shutter of the camera, and now switch on the lights of the room. Same thing is possible if you want to drop one pebble in a plate of water and or in a pool, and you want to capture the waves after dropping the pebble.
So for that, we must ensure that the speed of the sound is equal to speed of the bullet, na?
No, definitely you are that sound is traveling how much distance? Hardly 1 meter or so. Is it not?
Yes, sir.
So that does not matter much. So definitely your bullet and definitely your bullet speed, and even if it is higher than the sound speed, definitely it may be that you may be getting the image 2 meters away than the actual intended position. So what you can do is you can adjust the microphone position and the gun position to get the proper image of that bullet.
Yes.
You can get that particular ripple wave type of nature that is available on the plate of water by the same principle. So this sound activated switch has many such good applications also. So if you want to clap your hand and ensure that the door gets opened. So the door opening circuit, if it is connected to this particular two contacts, so that same effect you will be getting. As soon as you clap your hand, this switch is on, so this contact is made. So if this is your door opening circuit, that door opening circuit becomes activated. So this sound activated switch can be having many such useful applications.
স্যার
হ্যাঁ বলুন।
স্যার ওই অ্যাক্রস দ্য এসসিআর আমরা কোন জিনিসটা কানেক্ট করব যদি ক্যামেরার ইসি সিনারিওটাকে ইমাজিন করি?
Basically, whenever the SCR is on, the resistance of SCR becomes very small.
Yes,
Switching the capacitor means key. Shorting the capacitor means what?
Resistance very small, infinite current.
So that's the same thing you are getting here. Okay.
না স্যার ওইটাকে আমরা কোনটার মানে ক্যামেরার কোন পোরশনটা কানেক্ট করব? মানে ক্যামেরা সুইচ
আমার ক্যামেরা সুইচ যখন যেটা বলছো সেখানে কি বেসিক্যালি কি আছে? দিস ইজ দ্য সুইচ। যেই তুমি ক্যামেরা শাটারটা সুইচটা প্রেস করছো তখন এই কন্টাক্টটা মেক করছে।
Yes sir.
So as soon as that happens, your flash becomes on.
Yes sir.
So you have to take out that flash contact point. So you have to do some modification in that camera unit itself. So readily তুমি কিন্তু আমার যে ডিজিটাল ক্যামেরা আছে সেখানে কিন্তু এই পয়েন্টটা তুমি পাবে না। তোমাকে you have to open the camera module and do the connection. And
Yes.
That is better available in analog camera, analog DSLR camera. In those things, this is available. But digital camera, it will be difficult to get those 2 points.
Yes sir.
There are several operation amplifier standard ICs available in the market, and 2 of those ICs that you'll be using in the lab are IC 741 and 324. The 741 is one 8-pin device. This IC 741 is one 8-pin device whose individual pin inputs are given. Pin number 2 is the inverting input terminal of the op-amp. Pin number 3 is the non-inverting input terminal of the op-amp, and pin number 6 is the output terminal. Now, apart from these 2 input and output terminals, there are 2 other input terminals required. They are for the DC inputs, the plus minus VSAT levels. That positive DC level is given to the pin number 4, and the negative DC is given to the pin number 7. Now, pin number 8, there is nothing connected to the pin number 8. That means it is simply a floating pin. So that's why it is given as not connected, NC. Now, what about pin number 1 and 5? They're named as offset null terminals. Now, that means there is a facility in IC 741 for nulling the effect of the input offset voltage at the output, for nullifying the effect of the input offset voltage at the output. We have seen that due to improper of the level shifter stage, even if the input reference voltage becomes 0, the output may become a certain non-zero voltage. So what you can do here is through the pin 1 and 5, you can insert certain DC voltage externally to the internal circuit so that the level shifter can now try to ensure zero output in this new condition. New condition means in this new environmental condition, as the parameters have changed, the level shifter was not able to ensure zero output for the zero input difference. Now, in that situation, if the output is say some positive voltage, that means the effective input of offset voltage is positive or negative?
Negative.
Huh? Effective input offset voltage.
Yes, sir. That is positive. Yes, sir.
It's positive. So now through these null terminals, if you try to introduce certain negative DC voltage level shifter state, it may so happen that for one particular such input voltage, the level shifter is now able to ensure zero output. But remember, that will also be valid for only that particular time instant. After 1 hour, the input, the parameter conditions may be somewhat different. So as the parameter condition was somewhat different, the level shifter cannot ensure zero even with the externally applied DC voltages. You may have to readjust that external applied DC voltage through the offset null terminals. So basically, the offset null terminal, if this is pin number 1 and if this is your pin number 5. So through this terminal, I may apply one voltage, some DC voltage I am applying, plus or minus DC. It may be positive DC, it may be negative DC. But mostly this is one positive, negative DC. Now this is your pin number 1, this is your pin number 5. This pin number 1 and 5, they directly go to the level shifter stage. They directly go to the level shifter stage. So by change, if I move this wiper position, this negative voltage, the some part of the negative voltage is available through this pin number 1 and some part is available through this pin number 5. So due to the relative relative condition of this voltage and this voltage, maybe the level shifter is having some certain time positive voltage, maybe it is having sometimes negative voltage. So as a result, the level shifter is always trying to ensure zero output for the zero input difference voltage with the added help of this offset null facility. But remember, this is only available in IC 741. It is not available in 324. Why it is not available? Because this is not much of that use. Because even if you adjust for the nullified output of the DC output at the for the zero input difference voltage, you have ensured zero output voltage, but that will be valid only for that particular time instant. Even after 1 hour, that adjustment may not be valid. So always you have to go on adjusting. So that is very troublesome, and we hardly ever go for that one. So even if this offset null facility is available, in practical scenarios, that is not much of use. So this is the pin configuration of the IC 741 for 324. The 324 is a quad op-amp. What do you mean by a quad op-amp?
Four pins.
Four op-amp, individual op-amps are there in a single. How many IO pins are there required here?
14.
so far I have done only 12. What are the other two?
DC sources.
DC
Plus
sources.
minus VSAT.
So there will be one positive DC. There will be one negative DC. Okay. Now pins are assigned in this manner. 1, 2, 3. I am moving in the anti-clockwise manner, starting from this output. 4, 5, 6. It is very easy to remember. Okay, so this is the pin configuration of 3 to 4. Now,
Sir, এরকম naming কেন?
it is one standard practice. I do not know why.
Okay.
For any such a 14-pin quad IC, this is the standard practice I have seen.
Okay, sir. For all 14-pin ICs like this.
No, not for all this op-amp and comparator category.
Okay. Sir, আরেকটা জিনিস মানে plus minus VSAT to all of the op-amps, right?
Plus minus all of them. This, in fact, the DC supply will be common. DC supply will be common to the all components of this particular internal components, rather, all internal components. Okay, let it be one transistor, let it be one SCR, whatever it is, whatever internal components, circuit components are there, the DC supplies are common to all. Unless there is some potential divider type of thing. Okay.
Yes, sir.
So all the 4 op-amps will be consisting of the same plus and minus DC levels. Fine. Now these 741 and 324, they are mainly used in amplifier applications. Amplifier applications means, will they be in saturation region, operate in saturation region?
Linear region.
No, there will be only linear region. But remember, so far we have seen that nothing can be, these op-amps cannot be used in linear region in the open loop mode. So how can they operate in the linear region? That we'll see later. But in comparator applications, the output, one thing is sure, pretty sure, that the output needs to switch from minus to plus VSAT or plus to minus VSAT in how much time?
Nearly 0.
Ideally 0.
Nearly 0. So what is the requirement of the slew rate?
Infinite. Plus minus
infinite. Plus infinity.
So, but do have the operation amplifiers having infinite slew rate?
No, sir.
No, sir.
They are all having of the order of volts per microsecond slew rate. Maybe 10 volts per microsecond, maybe 50 volts per microsecond. That is the standard slew rate values. So the even if you go for that sine wave to square wave conversion using that ZCD, the output you will be getting something like this. These are limited by the slew rates. These slopes are limited by the slew rates. But ideally, what is your requirement? This is your
Square wave.
Square waves.
That's your requirement. So for specific comparator type of applications, we need a logic, we need operation amplifier circuits which are capable of handling much higher slew rate values as compared to the standard operation amplifiers. So for that, one special category of operation amplifier circuits have been designed and fabricated having very large slew rate specifically for the comparator applications. And in the market, they are available as in the name of comparators. They are hardly ever used in linear region. They do not have any linear application. They are only having non-linear or comparator applications. And that's why they are named as comparator ICs. One such comparator IC that we will study in the next class, today the time is already over, that is 339. We'll start in the next class from this 339 and probably in the offline mode. If you all want.
Yes, sir. Yes, sir.
Okay, fine.
Sir, what is the source of the name 339, 324, and 741?
741, 324 are the op-amps, and this 339 is called the comparator IC.
Why is the name?
Oh, what is the name? Oh, I cannot say that because the persons who are designing them, they are assigning certain name. Like your 7400, the NAND gate, quad NAND. Why not 7404? Why it is 7400? Nobody know. I do not know. I cannot say that. While fabricating, they have set up one committee, and that committee have associated the certain part number for certain categories of devices. So it is like that only. So these are all universally accepted part numbers. If you try to design your own in some foundry, then in that case, you can assign some other name. But once this 339 has been made public, whoever is designing or fabricating that, they has to use this 339, but before that, they can have their company prefix. Some Texas Instruments can have their company prefix. Linear devices, they can have their. Analog devices, they can have their. But the fundamental device part type, a part name, that will remain as 339 or 324 or 741.
So the number always remains constant and the prefix is available.
Component to component, that prefixes or suffixes, they vary. Okay.
স্যার আমার একটা ডাউট ছিল স্যার।
বলে ফেলো।
স্যার ওই অফসেট নুল পিনে দুটো পিনে কি সাইমালটেনিয়াসলি আমাদের এক্সটার্নাল ডিসি ভোল্টেজ দিতে হবে?
যেটা করা হয় 741 এ, এটা হচ্ছে এরকম থাকে। এই যে মাইনাস ডিসি ভোল্টেজ যেটা রয়েছে, সেটাই ওয়াইপারের সঙ্গে কানেক্ট করে দেওয়া হয়। পিন নাম্বার 1, পিন নাম্বার 5, দিস ইজ পিন নাম্বার 7। পিন নাম্বার 7টাই দেখো বোধহয় নেগেটিভ ডিসি রয়েছে।
ইয়েস
ইয়েস।
এবারে ওয়াইপার পজিশনটাকে যদি মুভ করাই, তাহলে যদি এদিকে থাকে, তাহলে কি হবে? পিন নাম্বার 1 ইজ গেটিং মোর নেগেটিভ দ্যান পিন নাম্বার 5।
Yes, sir.
And if it is moves towards the pin number 5, pin number 5 is becoming more negative than pin number 1. So, age relative negative voltage values that is coming to the level shifter stage through the pin number 1 and pin number 5, that will try to adjust, bring the level shifter output to either more positive side or toward the more negative side. By trying to adjust the output to be zero voltage.
So, sir, in any case, we are supplying negative voltage only.
Any case, we are supplying negative voltage only, but with the actual voltage is pin number 5 voltage with respect to pin number 1. So that can be positive or negative, isn't it?
Yes, sir. Yes, sir.
Yes, sir. Next, sir, man, relative voltage always supply করছি। Okay.
ওকে, তো আজকের ক্লাস এখানেই শেষ করছি। মনসুর অ্যাবসেন্ট, আশিস পাত্র অ্যাবসেন্ট, বৈভব অ্যাবসেন্ট, যোগেশ তিওয়ারি অ্যাবসেন্ট, মুস্তাফা কামাল অ্যাবসেন্ট, শুভলিন সিং অ্যাবসেন্ট, শিখা